Hello, my name is Dan Oak, and I'm a student at Athabasca University, currently taking the course Computer Science 444, Embedded Robotic Programming. I've had a couple of videos that I've done so far that I've put on the forum. Reference the nRF24L01 wireless transceiver module, which basically allows you to add wireless communication to your Arduino projects, so you can have two or more Arduinos separated, by some distance and control them wirelessly. It's a lot of fun. So here's a couple modules that I've used set up in the previous videos, where I've transmitted both text, like a string, hello world, from one module to the other, and where I've used a joystick to control a servo. So both those videos are on the forum. They're a little long. I am not a YouTuber by any means. So that's what we've done in the previous video. What I want to show you now is still doing the nRF module code, but I'm going to use buttons to control some LEDs. So let's get to that. And again, if you've been following along with these videos, thank you for your patience. We've run into some issues and troubleshooting in the last videos, but hopefully it's been helpful. So in the first tutorial video, I went over sending text back and forth, and I'm using, I should note, I've mentioned this in the other videos, but we're using the Autodesk Constructables tutorial that you can find online. I'm just kind of adding a little bit to it, or just really expanding on it and highlighting it. So we first sent text, and now we're going to light up LEDs. I kind of sidetracked with the second video by showing the use of using an analog joystick to control a servo motor, but that was just because they were already hooked up on the boards. But we're going to go, in order to follow the tutorials, we're going to get rid of this setup, and we have a couple new modules. So now I'm using Arduino Unos, but again, Nano, Uno, any microcontroller, the modules will work with any of them. Also, just one thing to note, in this case I'm using I ordered these ones, the external antenna versions, so that I can have increased range. Again, on the desk, the range doesn't matter. With the internal antenna, I'm gonna be fine, but these will give us extended range, whereas the internal antenna gives about 100 meter range. This will give about a kilometer range. And I've got the internal antenna hooked up on both of the modules. So, again, if you go to the Autodesk Constructables tutorial, you'll find the code to lighting up LEDs with push buttons. Schematics will be here, as well as the code. So again, the schematic is, the code was the same as before. The nRF24L01 module, the RF transceiver module, is hooked up as it was in the previous video. So if you've watched those, your hookup will be fine. Again, the main things are just make sure your power is hooked up to 3.3 volts, not 5 volts, that you will destroy the module, and ground is hooked up to ground as usual. There's a capacitor. You can have a 10 microfarad to 100 microfarad capacitor across the power. It just helps with the noise that comes from the signals and the power supplies. So this just helps with operation. It's not really going to come into play with how close we have these modules and everything like that, but I would recommend either soldering a capacitor across your power pins like I've done, or just include it in the breadboard. Make sure you keep polarity in mind. These capacitors, electrolytic capacitors, are polarized, so there will be a white line down one side that needs to get hooked up to your negative. Again, CE and your chip enable pin, those can be any digital pin. So I've got them on pins D9, D8. But your SPI pins, which is the serial clock, the master out slave in, and the master and slave out, do have dedicated SPI pins on the Arduino microcontrollers, as well as probably any of the microcontrollers out there. On the Nano and Uno, it's pins D11, D12, and D13 that you're going to hook up your pins master out, slave in, master in, slave out, and serial clock to. That just gives you better performance. It's not a hard, fast rule, but the library that we're going to be using does it that way, so it makes sense for you to do it as well. The only addition to the transmitter is that we've included a couple push buttons. And push buttons are hooked up to, I've got some pull down resistors going to ground, so that way I don't have a floating push button value between high and low. They'll be low and not pushed, and when we activate them they will go high. Alternatively, I could have made these had pull up resistors, or I could have used the code in Arduino. You can when you use your pin mode function, you can include as your second argument, instead of input underscore pull up, and you will get an internal pull-up resistor, which is like a 20K pull-up resistor in the microcontroller itself. So however you want to do the buttons, that's fine. The schematic, you can do it like this, which is how I've done it, or you can, so again, I've used the physical resistors as pull-down resistors, pulling them to ground. So this blue rail is hooked to ground to my Arduino, and then I've got the other pins connected to 5 volts. So again, they're pulled down to ground when they're not pushed, and when I push them, they will go high. And I've got the signal pins on the other end of the grounds going to a couple of the digital pins. So that is that part of the schematic. And again, the same for the receiver. The connection for your nRF24L01 RF transceiver module is exactly the same as the transmitter, and the same as it was if you follow the other two tutorials. And if you did, again, very patient. Thank you. We have our two LEDs on the receiver end hooked up as normal. So again, make sure you use a resistor for your LEDs, so you limit the amount of current going through them, and you don't have a big bright light that suddenly is no light. And then so again, the shorter end of an LED is the negative side, and the anode, the positive side of the LED, is the longer leg, so typically bent in order to fit in the breadboard properly, and those can go to any of your pins. So that's the schematic, and this is the actual circuit that I've hooked up. Again, I just showed you I'm using pull down resistors for the buttons. And for the LEDs, again, I have the grounds connected together through a single resistor. Kind of what they did, which is fine. I mean, you could just use separate resistors as well. But each of the shorter legs of the LED are connected into the same breadboard line, so that they're all connected together, which then are connected through a resistor to the ground rail, which I've connected to the Arduino. And then the signal, the positive side of each Arduino is connected to a wire that's connected to the Arduino. I've used red for the red LED, even though typically that's for power, so make sure you don't screw that up on yours. If you do use red like me, you're living dangerously. And blue I've used for the blue LED. So I did that for the video purposes, just so we could delineate the LEDs. Red LEDs on digital pin 5, blue LEDs on digital pin 6. But again, if you are going to use red wire for anything besides power, just be careful, because red is typically power and black by convention is ground. And as you can see, I've broken both cardinal rules by using a yellow wire as my ground wire. But as long as you know what you're doing, I guess it's fine. So keep that in mind. So we'll go back to where we were. Oh, went too far. So this is the thing, and the code I'm going to go to now. So I'm not going to bother pulling up their code, but basically you have two LEDs on the receiver end, two push button switches on the transmitter end, and when we push button 1 is pressed, the transmitter is going to send the text B1 using radio.write, and then when you press button 2, it's going to send B2. If you don't press anything, it's going to send 00. And then on the receiver end, we're going to use a switch statement to light up some LEDs. So let's look at the code that we have. So as you can see, this is the code I've set up for, this was for the previous example actually, transmitter joystick was sending the X value of the joystick to an Arduino. So this code is no longer necessary because this is old code. What we should be using now is, this is code for transmit the button using an if-else statement, if-else-if-else statement. And this is code to receive one LED at a time. So yeah, in the tutorial, you can only press one LED at a time to affect the LEDs. So if you press both buttons down, it's whatever button you technically press first is going to light the LED. So only one LED will be lit at a time by a button press. So I've stuck with the tutorial, so that's what I've done. But I've got other examples where I make it so that if you press both buttons, both LEDs will light. That's how I would have liked it, but I stuck with the tutorial for this. So let's go through the code. As usual, we include the same three libraries, the SPI library, because this module uses SPI serial peripheral interface communication protocol, and we include the nRF24 library as well as the library specific to the module. We create an instance of the module. So an instance of RF24, call it radio by convention, and pass in two perimeter arguments representing the chip enable pin and the CSN pin, which is the chip select not pin. The chip enable pin just basically is the power switch for the module, and the chip select pin just basically allows the microcontroller to communicate with the module. It says, hey, you there? I want to talk. I've hard-coded 9 and 8 in here using magic numbers. Obviously, you could have, probably better to do something like define, CE pin 8 and do something similar for the CSN pin, and or you could use, you don't have to use define, that's kind of an older convention. You could use const int CSN pin equals 9. Make sure I get those right. Now I got those backwards. So this would be 9 and this would be 8. You could do that and then put those directly in here, which I'll do for this example. It's sometimes better than just having magic numbers. I think I had, in all my tutorials so far, just have the pin numbers hard-coded in there because that's what the tutorials did, but probably better for to be explicit with these. Although with those two numbers, it's in the quick little comment here, you're probably fine either way. Then as usual, you're going to create your address. I've got this code used a one-dimensional array of type byte 10 of size 10 for their address, but still used a string of 5. So it doesn't matter. This could have been 6. It doesn't really matter. I just stuck with the tutorial code. The main thing to know here is so far the libraries that you're including for both the transmitter and receiver, as well as setting up an instance of your RF24 and your address, are the same in both code. Okay. Theoretically, the pin numbers could be different here, depending on what pins you had available on your second Arduino using as receiver, but the code is the same. And we've then got some on the transmitter side. Specifically, we have some code associated with the push buttons. So we've got a couple constants representing the button pin for button 1, which is on pin 5, and button pin 2 is on pin 6. I've used constant, kind of like the convention up here. Again, I could have also used defines, hashtag define, button pin 1, whatever you're into. But it's better than using hard codes for your button pins in case you change them, which I've done. I've also created 3 care one-dimensional arrays, so C-style strings, B1, B2, and 00, which will be using the code. And then on the receiver side, I have LEDs I've set up. But obviously I did a copy from the transmitter side and forgot to change the comments here because it says push buttons. So that's an LED, LED 1, which is, I don't know, the red one or the blue one, not sure, and LED 2. Okay, so again, I've declared a couple constants of type int for my LED pin 1 and 2, which are going to be on pins 6 and 5 respectively. In the setup code for both the transceiver, the transmitter, and the receiver, as usual, I'm setting up serial.begin in both codes, just because I'm obviously going to be outputting some stuff to the serial monitor. That doesn't so much have to do with the radio, because I don't need to do that, but I'm obviously doing that for demonstration purposes. And I've got a baud rate of 9600, and make sure the baud rate's the same in both the transmitter and receiver. In the setup for the transmitter, I've called the pin mode function and set up my button pins as inputs. And on the receiver end, I've called the pin mode function, setting up my LEDs as outputs. Then to get back to the RF transceiver code, I've called the begin function in both the transmitter and the receiver. And then on the transmitter side, I've done radio.open writing pipe. Again, writing pipe associated with the transmitter. I've set the PA level to max this time. Again, doesn't matter. I could set it to min because I'm right next to each other on the desk, but max will give you the maximum range when you're actually employing this project out in the real world. Because it indicates how much power amplification you're giving to the module, either if you're powering it directly through a microcontroller or through an external power supply. So I've made them the same on both the transmitter and receiver. And then I've called radio.stop listening on the transmitter side, which is important because you say stop listening to indicate that you're going to be transmitting. On the receiver side, I go start listening to indicate that I will be receiving. In the loop for the transmitter, I basically do a digital read of both button pins to find out what state they're in. They'll be in a state of low by default because I've got my buttons pulled to pull down resistors, pulling them to ground, so they'll be in a state of low by default, and then high when pushed. Then I use an else statement to determine what buttons press. So if button state 1 equals high, I'm going to write to, I'm going to use radio.write function to write, I'm going to reference text 1 and write that to the receiver. And I'm also going to print it on the serial monitor. What is text 1? Text 1 is B1. So it's the C-style string B1. So I'm going to write that to the receiver end and also print it on the serial monitor here. Else if B2 state, so the button number 2 is high, I'm going to write B2, which is what text 2 is, and I'm going to write that to the serial monitor as well. Otherwise, I'm going to write text 3, which is 00, which is just my indication that, the tutorial's indication that no button was pressed. And then I'm going to delay 100 microseconds, milliseconds rather, a tenth of a second, just to allow for some time to transfer. Now, I've done the if B1 state equals high because that's what the tutorial did. Obviously, this is kind of redundant and verbose. You don't need to do that. You could just go if B1 state. If it's high, it will be true. High is true. And if it's low, it'll be false. Low is false. So you can write it as either equals high, or you can just write the name of the button itself like this. I'll leave them both there just to show that either one is fine. So that's on the transmit side. It's the button presses. On the receive side in the loop, as usual, we're going to check if something's available to actually read, if something actually has been transmitted. So if radio.available, and then we're going to create a placeholder for the thing we're going to read in. So we're creating a one-dimensional array of type char of size 5, because we could have made it of size 3 really, because we're only ever sending either B1, B2, or 00, but we did 5 here in the tutorial, so it's fine. We've set it up to an empty string. That's important just so you don't have any communication failures. And then we're going to do a read, radio.read. And whatever we read in, we're going to store in this char one-dimensional array we just created. And then we're going to use a switch statement to figure out what to do, what LED to put on. So in the switch statement, we're going to take in text sub 1. So we're going to go to text, the thing we read in, and we're going to grab the thing at index 1. So we're not grabbing the first thing. What's that mean? Well, if we look at the things we're transmitting either B1, B2, or 00. So we're going to ignore the B's on this, and we're only going to grab 1, 2, because that's what index 1 is of the string, 1 or 2, or 0, it doesn't matter for this one. So basically that's going to allow us to either receive as a string 1, 2, or 0. We're ignoring the B, which we have just for indicating button. So case 1, so assuming our character is a 1, we're in a serial.print line. We're going to print to the serial monitor, blue LED on. I guess I have that hooked up to the blue LED. And I'm going to digitally write LED pin 1 high, which is obviously the blue LED. And I'm going to digitally write the LED pin 2 low. So in this tutorial, I'm only allowed to have one LED on at a time, just by the way it's set up. So if LED 1 pin is high, LED 2 pin is low, and then I break out of the switch. And then case 2, it's red LED on, so it's the opposite. I'm going to digitally write LED 1 pin low, digital write LED 2 pin high, and then break. And if I got a 0, it means I could have put actually case 0 here, but I guess I'm just doing default. We just do default and catch everything. Basically, if it wasn't 1 or 2, just shut both LEDs off. So I indicate that via the serial monitor, and then I write both LEDs as low. And that's it. And then I have a delay on this side as well, just so that things are happening at the appropriate speed. And I also serial print whatever I got to the serial monitor. So let's upload the code and see how this works. So I'm going to hook in the button pin. We're going to see what port that is. Port 16, Uno. Upload that. Okay, so that one's uploaded successfully. So now I've hooked in the other one. I can't remember what this one was. You know what? I've already forgotten. So I'm going to unhook this for just a second. Let's see what port. Okay, so 16 is still there. So this is port 15. Okay, and it's already reading as an Uno, so I'm going to upload the code on both of these. So they're both done uploading. So it's probably pretty fast to make it really, there's really no benefit to reading the serial monitor, likely, as the code is going pretty quick. I could slow that down, but then that delays the response of the button. So we'll just leave that for now. But as you can see, both LEDs are off. And you can see I'm not pressing anything, so that makes sense. If I press the red LED, you can see the red LED light up, and you can kind of see the code here. It's pretty quick, but red LED is on, and it's showing B2. So I guess that was what I hooked up to B2. If I press the blue LED, or the blue button, correction, we'll see blue LED on in the serial monitor, and that's button 1. But if I press them both at the same time, they're not both going to light up. In fact, obviously, I pressed B1, I guess, or I pressed the blue LED button first, but that's just something I obviously did without realizing it. But they both can't be on at the same time. I can either have red or blue, red on or blue on. It's just the way the code's set up, because it uses an if, else if, else statement. So again, only one of these will ever be true. I could have used if and then, made this if as well, and then change the code on this side, but I'm sticking with the tutorial, so we'll just leave it as is. But that's basically how this works. Again, just to, as I've done in all the videos, to show that they're truly wireless, I will unhook this from the computer, hook it into this portable power supply, unhook the other board as well, and you can tell the other board was unhooked because we no longer have wireless communication. So now we're fully just hooked up to a power supply. We're not hooked up to any computers or anything, and we can see that there is wireless transmission. So when I press the red button, the red LED lights up. When I press the blue button, the blue LED lights up, and we're not hooked to anything in the computer. And obviously this power supply isn't doing anything. I could have this hooked up to 2 individual power supplies. It's not like there's any circuitry in here that's communicating. It's just I have one down here and it conveniently has 2 connections. So that's that. Thanks for watching. Next time we'll do something else with the nRF24L01 modules. But as you can see, they're pretty fun little things to play with, and they can add a lot of a lot of fun to your projects just by allowing you to untether from the computer. Thanks for watching, and we'll see you next time.